Hey guys, welcome back. This is going to be one of my favorite videos. It's going to show you, basically it's going to use mathematics to show you what you probably already know just based on a picture. So I'm calling this increasing decrease, concave up, concave down. And so let's take a look at an example. I started with this example that I just threw out there, y equals x squared minus 2x. First I solved for the roots. So the roots are x equals 0 and x equals 2. I know that every vertex of a parabola, because this is a parabola, every vertex of a parabola lies between the roots, right? So at 1, -1. So I just drew that picture. If I were just to ask you, without using any calculus, where the function was increasing and decreasing, you would say, oh, it's decreasing all the way until +1, -1. So it's decreasing from negative infinity to +1. And then it's increasing from 1 to positive infinity, okay? And this guy here is called a minimum, okay? And now, when we have a shape that looks like a U, we say that the function is concaved up. This function is concaved up on the entire interval from negative infinity to positive infinity because it's not an upside down. If it was upside down, then we would say it's concave down. So right now, this is concaved up. We're going to use calculus to show this. So how do we do that? Well, if you remember from our last videos, we first have to take the derivative, which is 2x minus 2, and set it equal to 0. You're going to add 2 to both sides and then divide by 2. So that's going to make x equals 1. This is called our critical number, okay? Once we get our critical number, where the derivative equals 0, we're going to make a number line. We're going to choose a number here and here. And we're going to plug that number into f prime, which is the derivative, which is basically this here. Before I set this equal to 0, you guys should always go y prime is equal to 2x minus 2, okay? So I'm going to plug a 0 in here. Once I plug a 0 into the derivative, I get -2. All I care about is the sign. Once I plug in something here, like a 2, I get 2 times 2 is 4 minus 2 is positive. And this is just going to confirm what we already know based on the picture, that the graph is decreasing, from this interval here, negative infinity to +1, and then it's increasing from 1 to positive infinity. So that's great. Now, do you guys remember what that's called? X equals 1 is a minimum because it went down, then up. And if you want to find the actual point, you just plug the 1 back in here. So that's your minimum. Now, you might be asking yourself, well, what if we took the derivative again? Well, that's a great question. So our derivative, I'm going to use a black ink, is 2x minus 2. If you take the second derivative, you just get 2, or +2. There is no x to solve for, okay? This just says that it's positive. When it's positive, think about your grade if you got a plus instead of a minus. If you got a plus, you'll have a happy face. And therefore, since there's nowhere to solve for 0, the function is concaved up from, so I'm going to write down concaved up from negative infinity to positive infinity, just like the picture shows us. This picture shows us that the entire interval is concaved up. Now, what you generally are supposed to do is take the derivative of the derivative, set it equal to 0, and basically follow the same rules, okay? So let's try one more really quickly. I did this for the upside down parabola because it's a negative x squared plus 3. So let's figure this out. I just know based on the picture that from negative infinity to 0 to x equals 0, right? We're talking about the x's. From negative infinity to 0, I'm increasing, right? My slope is positive, right? And then I'm decreasing over here. My slope is negative. But let's use calculus to show that. The first step is to take the derivative. That's -2x. Set the derivative equal to 0. And so therefore x equals 0. That's what we call a critical number. we're going to put 0 on the number line. I'm going to call the number line f prime of x. You're going to pick a number below 0 and above 0. And so below 0, I'll pick -1. Once you put -1 into the derivative, -2 times -1 is +2. And if you pick a number from 0 and above, not including 0, so 1, we'll put that back into the derivative, you get a negative. And so this confirms our picture of us going up and then down, right? So the function is increasing and then decreasing, all open intervals, okay? So that means if I go up then down, 0 is a maximum, right? So what is the point? 0, and then you plug it back here. So the point is 0, 3. So that's a max. Well, what would happen if you took the derivative of the derivative? Well, that shows us concavity. So that derivative is -2, and there's no place to solve for x. That means the interval is concave down all the way from -infinity to +infinity, just like our picture. If you got a negative as a grade, then you would have a sad face, okay? So in our next video, we're going to discuss more concavity, and we're going to be solving, because we're going to see pictures that go like this: halfway, then halfway, and then halfway, and then half. So it's going to be concave down, then, so it's going to be concave down, and then up, and then down, and then up, and so on, okay? Here, we have no place to solve for x, so it's concave down the entire way. So I hope you enjoyed this video. Hit the like button, hit the subscribe button, and come